Hi Geometry, this is Unit 4, Lesson 8, and we're on page 485 of your workbook. I'd like you to take a look at the 4 triangles on this page. There are several things that we can notice that doesn't belong, but there is one thing in particular that I'd like to stand out to you. So take a moment, look at these 4 triangles. And the item that I hope is standing out to you is the fact that triangle C is not a right triangle. This is not a right triangle. Do not use your trig function, sine, cosine, and tangent, on a triangle that doesn't have a right angle. So most importantly, when we do these problems in our workbook, every triangle that we're working with is a right triangle. So before you use your trig, you need to verify that that's what you have is a right triangle. Let's take a look at the next page. I want to look at the first 2 triangles at the top of our page. So let's take a look at triangle A1 for a moment. I need to calculate x. So as I look in this triangle, I don't know anything about the side opposite. I do know the side adjacent is 7, and my hypotenuse, which is always across from a right angle, is what I'm trying to find. So using my SOHCAHTOA, it looks like I'm doing cosine because I have adjacent, I'm looking for opposite, and I'm looking for hypotenuse, and my opposite is not useful at all. So I'm going to set up a cosine equation with my angle, 41 degrees, and I'm going to say that it equals 7, my adjacent side over my hypotenuse, x. This is one of those problems where I need to multiply both sides by x because that's my variable and I want to get it up and out of the denominator. And so when I do that, I have x times cosine of 41 equals 7. But I'm trying to solve for x, so I need to get rid of my times cosine of 41. So let's divide both sides by cosine of 41 degrees. And when I do that, I get just x on the left side, and my right side is 7 divided by cosine of 41 degrees. So let's do that on my calculator. I'll use the light gray one for this calculation. I'm going to put my 7 in first, divide by, and now on this calculator, I'm going to touch the 41 and do the cosine of that. Now be very careful. That's just the number in my denominator. I need to do 7 divided by that number, so I'm going to hit equals. And it looks like x then is 9.275, 9.28. Depends if you're going to round, not round. We'll leave it like this. So now let's take a look at column B. When I first look at this, this looks like a different problem, which we'll see in a moment that it's not. But let's take a look at this problem. So my angle is 49 degrees. I can see when I look at this problem that I know that my opposite side is 7. I do not know anything about my adjacent side, it's blank, and my hypotenuse is x. So using my SOHCAHTOA, it looks like I'm going to write a sine equation knowing my opposite and my hypotenuse, and my adjacent's blank. So my sine of 49 degrees is equal to my opposite 7 over my hypotenuse x. Just like the problem on the left, I need to get that variable up and out of the denominator. So I'm going to multiply both sides by x to do that. And I get x times sine of 49 degrees is 7. However, I need to solve for x. So let's divide both sides by sine of 49 degrees. And when I do that, I have solved for x. So let's put that into my calculator. And this time I will use the Navy calculator. So on this one, I'm going to do 7 divided by, and on this type of calculator, I put the sign first, and then I put my 49 degrees in my parentheses, and I see, oh, wait a second. This is the same answer, 9.28 when I round, that I got last time. So I want to point something out to you. We know that the two acute angles in a right triangle have to be complementary. So the 41 degrees and this angle up here have to add up to 90 degrees because 90 plus these two have to equal 180. So these two also have to be 90 because 90 and 90 is my 180. So let's find this angle up here. So 90 degrees minus 41 would give me 90 minus 41 gives me 49. So this is 49 degrees. So then when I'm looking at this triangle right here and I see the 49 as one of my acute angles, I know that it's got to be complementary to this angle here. So I know that my angles are 41 and 49. These are the same two triangles. All they did was flip the triangle so that my 41 degrees was at the top and my 49 degrees was at the bottom. So then the bigger thing that is the takeaway from this lesson is notice at the third step, my equations are identical, except here I divide by cosine of 41, and here I divide by sine of 49. But look, I'm getting the same answer. Let's take a look at that, shall we? The cosine of 41, let's put that into our calculator. 41 cosine is this number, okay? Let's take a look at the sine of 49. So sine of 49 equals, well, they equal the same thing. They equal the exact same number. So I know from doing this problem that the cosine of 41 degrees is equal to the sine of 49 degrees. That is always true. My two acute angles in a right triangle, the cosine and sine of each of them are equal to each other. Let's look at a few examples. So out to the side, please write cosine. We'll do easy numbers for this. 30 degrees equals sine. Leave a big space for your parentheses. Okay, how about let's do sine of 70 equals cosine. Leave a big space. Let's do cosine of 25 equals sine and leave a space. I can figure out the number that goes inside there. This is the other acute angle of my right triangle. My two angles are always complementary. So the cosine of 30 has to equal the sine of, well, the 30 and this angle have to total to 90. So this must be 30 and 60. Okay, well then set the sine of 70 equals the cosine of what? Well, this angle and this angle have to be complementary. They have to total to 90. So this must be 20. You're right. And 25 and 25 degrees in this angle must be complementary. So they must total to 90. Be careful, total to 90, not 100. So this would be 65 degrees. So the two acute angles of a right triangle, the sine of one is the cosine of the other, and vice versa is true. So up here at the top, I could have also done the sine of 30, and I would know that that's equal to the cosine of that same 60. So let's take a look at this in more formal writing on the next page. It says, draw a diagram to help you explain why the sine of theta, that's an angle, is equal to the cosine of 90 minus theta. That's my other acute angle. Let's take a look at a right triangle. Let's sketch a right triangle. Put your 90 degrees in your right triangle and put your theta. Well, remember, my two acute angles are complementary. That means they add to 90 degrees. So if I want to find out this angle, I simply do 90 minus theta. So this angle right here would be equal to 90 minus theta. Hence, those are my two measurements. If this is 30, this is 60. If this is 20, this is 70. If this is 40, this is 50. So to get this angle, I'm going to subtract whatever theta is from 90. So it says explain why sine of theta equals cosine of this. Well, let's just put some variables here. We'll call this A, B, and C. So let's find the sine of theta. If I'm working with theta, if theta is my angle, then C is my side opposite, A is my hypotenuse. So the sine of theta is opposite over hypotenuse, or C over A. So now it says to find the cosine of 90 minus theta. That's this angle. So let's re-look at my triangle. This is my 90 minus theta angle. And cosine is adjacent over hypotenuse. So C would be my adjacent side. A is still my hypotenuse. It's across from the right angle. B is my opposite. I don't need it to do cosine. So cosine would be C over A, adjacent over hypotenuse. Well, take a look. They're equal to each other. So when you're given a right triangle, I know that the sine of theta is going to be equal to the cosine of whatever 90 minus theta is. I also know that the cosine of theta will be equal to whatever 90 minus theta is. So this is my relationship for the two acute angles of a right triangle. They're complementary to each other, and so we have this cool relationship between the sine and cosine of each of them. Thank you very much.